Okay, so we're going to look at 1.7, which is transformations of functions. Okay, there are multiple kinds of transformations of functions. The first type is a vertical shift. Okay, so like f of x plus c, when you're adding something to x, that moves your graph up. It's a vertical shift up. F of x minus c is going to be a vertical shift down. So you would go down c units. For horizontal shifts, if it's inside the parentheses, f of x plus c, that means you're moving it to the left. You're moving it in a negative direction. You do the opposite of what's in your parentheses. And then f of x minus c would move it to the right. It would move it in your positive direction. Okay, so let's look at example 1a, where we're graphing the function g of x equals x cubed minus 1. Okay, so if we start with our parent function, f of x equals x cubed being our parent function, and then we graph that, then we know that our function f of x looks something like that. That's what your parent function of a cubic graph looks like. So then if we graph g of x equals x cubed minus 1, that minus 1 tells me that I'm going to have a vertical shift, and I'm going to have a vertical shift going down 1 unit. So I'm going to move everything down 1 unit, and then I can graph my function g of x. So I don't have to make a table of values. I can just start with my parent function and then look at what kind of shifts I'm doing. So if I do the same thing for h of x equals x plus 2 cubed plus 1. I'm again going to start with my parent function, f of x equals x cubed. That comes from my x cubed. Okay, so that's my parent function. Okay, so then if I look at my secondary function, my h of x, I have a plus 2 here and a plus 1. The plus 1 I know is going to move my graph up 1. It's a vertical shift. And then the plus 2 is going to move it to the right 2 units, because we always go in the opposite of what we're doing. So we're doing that. Then we're going to go right 2 units and up 1 unit. So this point actually shifts to right there, my center point, because I went over 2 and then up 1. And then if I finish graphing those, then I know that my new function would look like that. Okay, so let's look at then reflecting graphs, because that's the third type of transformation you can have as a reflection. So if you're reflecting it over the x-axis, all that does is change the function to be negative. So f of x would actually equal negative x. If you're reflecting it over the y-axis, then you're changing your x, not your whole function. So it would be f of negative x. All you're doing is changing the x value, not the whole function. Okay. So if we look at example 2a, we have our parent function x to the 4th. That's our parent function. And we want to figure out what happens to our second function. Okay, so we're going to try to rewrite a function based on this graph. And I know it's going to be something to the fourth power because I started with my parent function. So I need to figure out what I did to it. So I clearly reflected it, which means that I reflected it over the x-axis, which means the whole function is going to be negative. And then I also moved it up 2 units, so I know that I'm going to be adding 2 units to it. Very good, negative x to the fourth plus 2, because my f of x was actually just x to the fourth. That was my parent function. So if I just change that to the x to the fourth, and then distribute that negative, negative x to the fourth plus 2. Okay, so let's do another one like that. So we have my x to the fourth graph, that's my f of x, and I need to figure out what I did to get g of x. So f of x equals x to the fourth, and I need to figure out how to get g of x. Okay. So again, my graph is reflected over the x-axis, which tells me that I need to make my function negative, negative f of x. And in this case, it's moved to the right, nope, yes, to the right. That's to the right. 1, 2, 3 units. And when I'm moving it to the right, I actually do the opposite. So that goes in my parentheses. So it's going to be x minus 3, because when it's moved to the right, you do the opposite. So minus 3, and that goes in my parentheses. So I'm actually getting negative f of x minus 3. That's my function. So then if I plug that in, then I get negative x minus 3 to the fourth power, because my function was x to the fourth power. That's it. Okay, so all we're working through is reflections, and we're going to work through vertical shifts and horizontal shifts. You're going to want to use the parent functions on page 70 to help you, because those will show you what the original function is supposed to look like. And you guys are going to work through page 78, 7 through 8, 11, 15 through 20, 25 through 28, and 55 and 56.